you might ask the following question. Could these lines of simultaneity in relativity not be parallel in a particular frame? Well, this leads to disaster. If two lines are not parallel, they cross. And let's look at one of those crosses. We could have then three events, A, B, and C, where A and B are simultaneous on one line of simultaneity, and C and B are simultaneous along another axis of simultaneity. A is simultaneous with B, because they're on a line of simultaneity. B is simultaneous with C, because they're on a line of simultaneity. So A and C are simultaneous. We've imagined that this is all happening in one frame of reference. But this leads to very bad things. If A and C are simultaneous, then I, just standing here, could be simultaneous with a future self, or with my past self. I could meet myself at another time, and this leads to no good and violations of the most elementary ideas of causality. One final set of notes here. Minkowski labeled this absolute world, as he called it, in the following way. He imagined space-time, t and x, where we had a light line, a light flash coming from the left and going off into the future on the right, and one from the right going off to the left. That carved up the frame of space-time into quadrants. In the future, which he labeled the absolute future, is all of the space-time points that are in what's called the forward light cone, all the points in space-time between the two light lines. It's called the absolute future because if I at the origin can causally affect something else in that forward light cone, then no other frame should ever be able to say that that causal relation didn't occur. In other words, if I take a ball and I knock over a chess piece, it's not going to be that in another frame of reference that didn't happen, or it happened in some other order. The causality actually has to be preserved, looked at from one frame to another. You can't go by in a train and see that I didn't knock over that chess piece. Conversely, something in the past could affect me, because from anywhere in that backwards light cone, you could get to me slower than the speed of light, just like you can get to the absolute future from the origin slower than the speed of light. In the parts that are to the right and left of this forward and backward light cone, you'd have to connect the origin with other points faster than the speed of light. So in the backwards light cone, an event could cause something at the origin, and all different frames would agree that that had happened. In the forward light cone, the absolute future, anything that I do at the origin that affected some event in the future would still be assented to as having happened in another frame of reference. But in the absolute away, very strange things can happen. If I have an event at the origin, say I snap my fingers, and in one frame of reference it happens before some event in the absolute away, I can choose another frame of reference such that the x prime axis is above that point, and I would then see that the other event in the absolute away occurred before the origin. So the time ordering of two events, where one of them is at the origin and the other is in the absolute away to the right or the absolute away to the left, can be changed. There can be no causal relation there, but there can be a reordering of the time sequence of events. And that's how Minkowski saw this: an absolute future, an absolute past, and then the absolute away in which no causal relations could ever be linked to the origin. These ideas of Minkowski about the graphical presentation of space and time, about how simultaneity should be understood, and much more, became absolutely fundamental to the idea of relativity as Einstein understood it, and was integrated into the building up of general relativity. In fact, Minkowski showed, and we'll talk about this in one of the questions and the ancillary discussions, there is actually a distance that could be defined in space-time, and that distance would be the same no matter what frame you were in. Einstein took that idea of distance in Minkowski space-time and extended it and developed it in completely unexpected ways to make a fundamentally new physics of the universe.